Greetings. In this video, we will be talking about the 4 different methods for solving quadratic equations. This can be accomplished by factoring, we can use the square root property, we can complete the square, and finally, we can use the quadratic formula. As always, you should go to our Blackboard page to see which sections will be covered by exam number 4, and you can see the due date for exam number 4 is next week Tuesday, June 11th, and this is a proctored exam. So what I'd like to do in this video is take a look at 10 different quadratic equations, and then we will solve them by using the square root property, completing the square, and the quadratic formula. I will not take time talking about factoring in this video, as we already did a video on factoring, and we've come off exam number 2, which was all about factoring. Make sure that your factoring remains strong because you're going to need to continue to use it throughout the remainder of this semester. All right, so let's come back to problem number 1. Here, the directions say solve using the square root property, and we are given that x squared equals 4. So, in this problem, we'd easily be able to do this in our head. We simply just need to think to ourselves, what number or numbers squared would give us 4? Well, we could take 2 squared equals 4, but we can also take negative 2. So negative 2 times negative 2 is also a positive 4. So for this problem, we would end up with 2 solutions, x equals both positive and negative 2. Now, we could have solved this problem by factoring, because all we need to do for factoring is make sure that it's in the correct form, and all that means is we just set one side of our equation equal to 0. So here, if we would subtract 4 from both sides of the equation, we would get x squared minus 4 equals 0. X squared minus 4 is the difference of squares, so therefore it would factor to x plus 2, x minus 2 equals 0, and then use the 0 factor property, set each factor equal to 0, and we would see that x equals both positive and negative 2. But here the directions are very specific in saying that we must use the square root property. For exam number 4, I'm going to require you to solve quadratic equations using all 4 methods. So this means if the directions tell you to solve an equation in a very specific way, you must do so, or else you'll lose all points for that problem. Basically, all I'm saying is just make sure you know how to do all 4 of these different methods. All right, so coming back to this problem, what we want to do is solve using the square root property. The first thing we need to do is introduce the square root property. So that's number 2. Here, this says if I have got a factor squared set equal to a constant, or in other words, if I just have something squared equal to a number, then all I would need to do is introduce a square root on both sides of the equation. So the reason this would work is actually coming off our last exam. We could use our radical identity that says, if my power matches my index, we get to cancel the radical, cancel the power, and we're left with just the radicand. So here for the square root property, all it's saying is to get rid of a square on x, we would introduce a square root. And the reason this works is our radical identity as x squared under a square root is in fact just x. But whatever we do to one side of the equation, you must do to the other, and this is where the first real caveat comes in. Anytime you introduce a square root, you must introduce plus or minus. So once again, what we said here is if I have something squared equal to a number, all we need to do is take the square root on both sides of the equation. Square root of x squared is x, but anytime we introduce a square root, you must introduce plus or minus. And the reason why is to account for both answers we can get if we square something. So that's what we saw here when we did this in our head. 2 and negative 2 squared are 4. That means anytime we introduce a square root, you must introduce plus or minus, or else you're going to be missing half of your answers. All right, so let's take this idea and come back over here. So once again, all this means is I need to have it in the correct form. I need some factor, and that can be a variable squared, or it can be a factor like x plus a or x minus a squared, that is still something squared, equal to a number. Well, that's exactly what we have here. We have something squared equal to a number, so all I need to do to get rid of the square on x is introduce a square root on both sides of the equation. But anytime you introduce a square root, you must introduce plus or minus. So here, the left side, my power matches my index. So that means we get to get rid of the radical, get rid of the power, and we're left with just our radicand. So our left side becomes just x. And on the right side, we have plus or minus the square root of 4. Well, the square root of 4 is simply just 2, so we get plus or minus 2. So that's exactly what this symbol means. It is both positive 2 and negative 2. This is just another way of showing two different answers at the same time. But here you go. We get both the positive and negative 2 we expect when we take a look at x squared. All right, so let's go ahead and take another example. Let's take a look at number 2. We get x squared is equal to the fraction 16 over 25. So here for number 2, we get x squared is equal to 16 over 25. So once again, we need to use the square root property. So that means I need to get it in the correct form. I just need something squared equal to a number. Well, that's exactly what I have. Even though this is a fraction is just a number. So I have got something squared equal to a number. We can go ahead and use the square root property. To get rid of the square on x, we introduce a square root. But anytime we introduce a square root, you must introduce plus or minus. So here what we see is we got square root of x squared. So here my power matches my index. Get rid of the radical, get rid of the power. And we're going to be left with just the radicand. So we're left with x. And on the other side, well, here we have a fraction under a radical. So we can go ahead and use the quotient rule to break this up into two different radicals. So we would get plus or minus the square root of 16 divided by the square root of 25. And this is helpful because we know both of these square roots. So we get x equals plus or minus 4/5. And there it is. These are the two numbers that if you square it, we would get 16 over 25. 4/5 times 4/5 is 16 over 25, but also negative 4/5 times negative 4/5 is also 16 over 25. So once again, this is how we use the square root property. This requires us to have something squared equal to a number. All right, so let's go ahead and take a look at another problem. So here for number 3, we have the quantity x plus 4 squared is equal to 4. So once again, we want to solve by using the square root property. We have x plus 4 squared is equal to 4. So again, to use the square root property, we simply just need something squared equal to a number, some factor squared equal to a number. Well, this is a factor. X plus 4 is its own factor, so what we see is we do in fact have something squared equal to a number. So we can use the square root property. So all we need to do to get rid of the square on x plus 4, we introduce a square root, but anytime you introduce a square root, you must introduce plus or minus. So the left side, my power matches my index. We cancel the radical, we cancel the power. We're left with just the radicand, which is x plus 4. On the other side, we end up with plus or minus the square root of 4. Well, the square root of 4 is 2. So the goal here is we want to solve for x and make sure that it is simplified. So to get x by itself, we have an addition of 4. We can subtract 4 from both sides of the equation. However, we now have a new rule when we are dealing with addition and subtraction with a plus or minus symbol. So what I'm saying is, here I have a plus or minus symbol on the right, and we are either adding or subtracting on this equation. Anytime we add or subtract, you must keep it to the left of your plus or minus sign. Once again, this is a very important concept that you need to know, or else you're going to end up with one incorrect answer. So once again, whenever we add or subtract, when we have a plus or minus symbol, you must always keep that to the left of the plus or minus. So that means here, if I want to subtract 4, I need to subtract 4, but it must be to the left of the plus or minus symbol. So that means here we would have x equals -4 plus or minus 2. If you were to put the -4 after the 2, you're going to end up with one incorrect answer, and I'll show that at the end. Now, this is not simplified because we know what -4 plus 2 is, and we know what -4 minus 2 is. So what you need to do is just simplify completely. We get two equations. X equals -4 plus 2, but we also get x equals -4 minus 2. So here, when we just go ahead and add and subtract, we get x equals a -2, and we get x equals a -6. These are the two solutions to the original problem, x plus 4 squared equals 4. Now, this is the answer that you get when you keep it to, when you keep any addition or subtraction to the left of the plus or minus sign. What were to happen if you put it to the right of the plus or minus sign? Well, if we did that, we would get x equals -4. In fact, my head, it won't even let me do it because I know this is the incorrect way. So I really have to think to do it incorrectly. I'm saying if we accidentally had plus or minus 2 minus 4, well, what we would see is plus or minus 2 minus 4 is -2. So we would get that x equals both a positive -2, which is -2, which is one of our answers, but we would get a negative -2, which is a positive 2. This is not the correct answer. So make sure you do not make this mistake. There are different rules for addition and subtraction than there are for multiplication and division. So let's go ahead and take a look at a problem like that. So for number 4, we have 2 times the quantity x minus 2 squared is equal to 24. So once again, we need to use the square root property. So for number 4, we are given 2 times the quantity x minus 2 squared is equal to 24. So again, we must use the square root property. However, you need to make sure that it is written in the correct form. The correct form says we need a factor by itself squared equal to a number. We do not have that here. We have this multiplication of 2 out front. This is not a factor squared equal to a number. This has a multiplication of 2. Now, you can still get there, but it's going to be a lot more difficult. So what you should always do first when using the square root property is to simplify and isolate the factor squared by itself first. So once again, we have 2 times the factor x minus 2 squared. Let's go ahead and divide both sides of my equation by 2. When I do this, I get x minus 2 squared is equal to 12. Now we have it in the correct form. This looks like what we need here. We have something squared equal to a number. We don't have multiplication. We don't have division. We don't have addition or subtraction on the factor. We need to get the factor by itself squared. Get the factor squared by itself first. So now that we have this, we have something squared is equal to a number. Now we can use the square root property. To get rid of the square on x minus 2, we introduce a square root on both sides of the equation, but anytime you introduce a square root, you must introduce plus or minus. And again, this is a requirement or else you're going to be missing half your answers. I always get a handful of students every single semester who forget the plus or minus. You automatically lose half your points because you only have half your answers. Make sure this is a note that you are writing for yourself. All right, so when we take the square root on both sides of the equation, my power matches my index. We get rid of the radical. We get rid of the power. We're going to be left with just the radicand of x minus 2. But then on the other side of the equation, we get plus or minus the square root of 12. So I don't know the square root of 12, but we can use the product rule. And in fact, as long as I've got it sitting right next to me, we can use the product rule to break one radical into two. So what we can do here is look for two factors of 12 where we know the square root. Those factors will be 4 and 3. So what we'll do is we'll take the power rule, and we're going to get plus or minus the square root of 4 times the square root of 3. We can simplify the right side of this equation. We get x minus 2 is equal to plus or minus 2 square roots of 3. So the last thing we need to do here is just get rid of the subtraction of 2 by adding 2 on both sides of the equation. But once again, anytime you add or subtract with a plus or minus sign, you must keep it to the left of the plus or minus sign. So that means here, the answer that we get is x equals a positive 2 plus or minus 2 square roots of 3. So in this particular case, we can see sometimes our answers are not going to be nice numbers. And in fact, a lot of the times, we're going to get radicals for answers. Now, I didn't show it here, but make sure that you watch the videos and read the ebooks. But if we have multiplication or division that goes across, we need to make sure that it goes across the entire piece. So let me give you a very quick example here. So let's say we have 9x is going to be equal to, 3 plus or minus 6 square roots of 2. So it doesn't really matter what it is. So let's just say this is where we end up with a problem. So we get to the point where we have a multiplication of 9 on x. So to get x by itself, we would divide by 9. But again, it's only addition and subtraction that we need to make sure that it stays to the left of the plus or minus sign. But if we multiply or divide, we still do it over all parts of the right side of the equation. So again, this is just an example to show you x would equal, well, 3 divided by 9 would just be 1/3, plus or minus 6 divided by 9 is 2/3, and we get 2 square roots of 2 over 3. So make sure that you know these pieces. These are the subtle nuances that make this exam very hard. You need to make sure you know what to do in very specific scenarios. And in this case, I showed you 2 of them. So once again, make sure that you get the factor by itself first and then take the square root on both sides. Anytime you introduce a square root, introduce that plus or minus sign. But also, when it comes time to solving for x, if we are adding or subtracting, you must keep it to the left of the plus or minus sign. But if you are multiplying or dividing, we still do that across the entire right side, both left and right of the plus or minus sign. All right, so this covers everything that we're going to talk about for the square root property. So the next thing that we want to look at is solve by completing the square, and eventually in that process, we're going to have to come back and use the square root property. So completing the square is one of the more tedious things in an algebra class. There's a lot of steps, and it's very time consuming until you get used to it. But it's simply a pattern. If you can simply just identify the pattern and then do it and do it again and again, eventually you will just get into this habit of completing the square. So again, if you haven't done it yet to this point, it is a little tedious. If you already know how to complete the square, then you're in good shape, because we need to, you must use completing the square when we get to section 15.1 and 15.2 when we talk about the standard form of a parabola. But we're not there yet. We'll get there. For right now, what we want to do is take a look at example number 5, solve by completing the square. We get x squared plus 4x is equal to 5. So now we're going to introduce the third method for solving quadratics. And again, it's the most tedious of them all. This is called completing the square. So in order for us to complete the square, we need 2 things. So once again, in order to complete the square, we need to have two things before we even start. So the first thing you must do is make sure that a is going to be equal to 1. So a comes from the standard form of a quadratic, ax squared plus bx plus c. And what that says is a, the coefficient on our variable squared, must be equal to 1. And if it doesn't equal 1, you must force it to equal 1. So again, all this is saying in a lot of words is that in order to complete the square, the coefficient on your variable squared must be 1. And if it is not 1, you must force it to be 1. And we'll show that in example number, well, I guess 7. I see that's the one that's coming up. So the second thing we need to complete the square is we need to isolate the terms with the variables by itself. So what do we mean by that? Let's take a look at example number 5 right here on the page. We have two terms that have variables in it, and we have one term that doesn't. So the two things that we need to do is make sure that a equals 1, the coefficient out in front of our variable squared, and also we must get the two variable terms by themselves on one side of the equation. Because the standard form that we're going to need are the two variable terms by themselves. We're going to literally keep a blank space after that, and this is going to be, equal to some number with another blank space. And I'm going to explain this in just a minute. So it is going to be much easier to show you the process of completing the square than it is to try to explain every single detail. That is what the ebook is for. That is also what the other lecture videos are for. And again, I don't care where you learn your materials. You can go to YouTube, Google. I don't care where you learn it, just as long as you learn it. So what I'm going to do here for number 5 is I'm going to complete the problem and I'm going to talk the process through. All right. So here for number 5, we have x squared plus 4x is equal to 5. So if we want to complete the square, we need to have two things happen here. So we get x squared plus 4x is going to be equal to 5. And there's a reason I wrote it this way. So again, in order for us to complete the square, we need two things to happen. A must equal 1. The coefficient in front of x squared must equal 1. Here, there's nothing written, so it is equal to 1. We have passed this check. The second thing is we need to isolate the variable terms by themselves. Well, these are the two terms that have variables in them. They are by themselves on one side of the equation. So therefore, we are set up to complete the square. So you should get in the habit when you complete the square to literally do it like this. Take the two variable terms, keep a space, and then what you want to do is literally go plus and then keep a blank space because we are literally going to be adding a term to our equation. And then this will be set equal to your number. And then once again, I'm literally going to put plus a space because whatever I do to one side of the equation, you must do to the other. So that's why it's replicated on the other side. All right. So when we want to complete the square and we have the form set up, what we need to do is add a number to the two variable terms such that it will make it a perfect factor. So this means we want to find something, and it should say a perfect trinomial. So that just means when I would factor my answer, I would get two identical factors. So let's just give a quick example. If I were to have x plus 2 times x plus 2, these would be two identical factors. We can rewrite this mathematically using exponents. Exponents are repeated multiplication. So x plus 2 times x plus 2 is going to end up being x plus 2 squared. And this is the key to be able to finish completing the square. So just keep this in mind. When we factor, we eventually want to get two factors that are the same. To accomplish this, we are going to add a very specific number to the left and right side of our equation such that the left side becomes a perfect square trinomial, which just means when you factor it, you will get two identical factors. How we find what we add comes from what we need in the missing term. This will be 1/2 of whatever your b is, and we're going to square that. So once again, a, b, and c, this is the same thing for the AC table when we actually factor. But a and b will come from the coefficient out in front of our variable squared and the coefficient out in front of x. So what we should do is identify a and b. So here a is 1, and we need that to happen. That's the first thing you need in order to complete the square. And my b is a positive 4. So that means to find our missing term, we need to take 1/2 of b, and then we're going to square that. So here, b is 4, so we're going to get 1/2 of 4 squared. Half of 4 is 2 squared. And then what I'm going to do is I'm actually going to put a little star right here at this spot. It's not a very good star, but it's a star. And I'm going to come back to this, and we're going to show why. So finishing this out, 2 squared is equal to 4. So what this means is when you take 1/2 of b, and square it, the answer you get is the number we need to add in order to turn it into a perfect square trinomial, which just means the factors will end up being the same factors, which we can rewrite as that factor squared. So here we are going to add 4 to both sides of my equation. Again, the reason we have to do it to both sides is whatever you do to one side of the equation, you must do to the other. So if I'm going to add 4 to the left side, you must add 4 to the right as well. So by adding 4 to the left side of the equation, we can actually factor this. We need 2 factors of 4 that have a sum or difference of 4. Well, those 2 factors are going to be 2 and 2. In order for me to get a positive middle term, my biggest number needs to be positive. Well, they're both the biggest number. They both need to be positive. And we can check our work. X times x is x squared. 2x's plus 2x's is 4x. 2 times 2 is 4. That's exactly what we have. So this is what we were trying to accomplish. We were able to factor and get a perfect square trinomial, which just means our 2 factors are identical, and we're going to be able to rewrite this as that factor squared. So we still need to finish out the rest of the problem. On the right side of the equation, we now have 5 plus 4, which is 9. So I can carry this down, and we end up with x plus 2 squared is equal to 9. Well, this just happens to be the square root property. Look what we have. Something squared equal to a number. That's all we need. This is the form we need. And this is the reason why we complete the square, is to get to this point where we can use the square root property. So I have something squared equal to a number. To get rid of the square on x plus 2, I can introduce a square root on both sides of the equation. Anytime you introduce a square root, you must introduce plus or minus. My power matches my index. We get rid of the radical. We get rid of the power. We're left with the radicand of x plus 2. On the other side, we get plus or minus the square root of 9. Well, the square root of 9 is 3. And then finally, to get x by itself, we can subtract 2 on both sides of the equation. But again, anytime we add or subtract with a plus or minus sign, you must keep it to the left of the plus or minus sign. So we end up with x equals negative 2 plus or minus 3. This is not simplified because this is just 2 equations. We get x equals negative 2 plus 3. And we also get x equals negative 2 minus 3. So x equals both a positive 1 and a negative 5. We end up with both answers. And if you were to plug this back into the original equation, you would in fact get true statements. So again, when it comes to completing the square, it is quite tedious and there's a lot of steps involved, but it's a pattern. Once you figure out the pattern and do it again and again and again, eventually you pick up on what you need to do. So we're just going to do another problem to show everything that we need to do in this problem. So for completing the square, you need 2 things to happen. Your a, your coefficient out in front of your variable squared, must equal 1. And if it doesn't, you have to force it. We'll show that later on. and you must get the two variable terms by themselves. So let's go ahead and take a look at problem number 6. So we're still going to solve by completing the square. I've got a lot of paper going on here. All right. So for problem number 6, we are given x squared minus 2x minus 8 is equal to 0. So once again, in this problem, we could factor this very easily and find our answers. Well, when we factor this, 2 factors of 8 that have a sum or difference of 2, looks like that's going to be 4 and 2. We're going to get x minus 4, x plus 2. So our answers are going to be 4 and negative 2. Factoring is always going to be the fastest way to do this, by the way, but you have to follow the directions, and the directions here say complete the square. So what we need to do to complete the square, we need 2 things to happen. We need to make sure our a, our coefficient out in front of x squared, is equal to 1, and here it is. So we have the first piece. The second piece says we need to isolate the 2 variable terms by themselves. We do not have that here. So we need to isolate the 2 variable terms by themselves. We're going to start by adding 8 to both sides of the equation. So what we're going to end up with is x squared minus 2x. I'm going to literally leave myself a space. And this is going to be equal to 8. And again, I'm going to leave myself a space because we need to add a number such that the left side becomes a perfect square trinomial. So what we need to do to find that missing number is take 1/2 of b and square that. So let's go ahead and identify our a and our b. So here our a is 1, my b is negative 2. So we're going to take 1/2 of b and we're going to square that. So here we're going to get 1/2 of negative 2 squared. Half of negative 2 is negative 1 squared. And again, what I'm going to do is I'm going to put myself a little star here. I'm going to come back to this. Negative 1 in parentheses squared is a positive 1. So this means to make the left side a perfect square trinomial where we get 2 factors that are identical, we need to add 1 to both sides of the equation. So that's exactly what we're going to do. I'm going to add 1 to both sides of my equation. When I do that, we're going to factor the left side. I need 2 factors of 1 that have a sum or difference of 2. Well, the only 2 factors that we have for 1 are 1 and 1. The only way I get a negative middle term is my biggest number needs to be negative. Well, they're both the biggest number, so they both need to be negative. So there we go again. We get 2 factors that are identical. We can rewrite this as x minus 1 squared. So on the right side, we need to make sure to finish this out as well. We get 8 plus 1 is going to be equal to 9, and we can carry this down. And then again, look what we have. We have something squared equal to a number. We can use the square root property. To get rid of the square on x minus 1, we're going to introduce the square root on both sides. But anytime we introduce a square root, and I'm going to say it 50 more times, you must introduce a plus or minus sign, or else you're missing half your answers. So on the left side, the power matches my index. Cancel the radical, cancel the power. We're left with just the radicand of x minus 1. And on the right side, we get plus or minus 3. So the final things that we need to do here is get x by itself, add 1, but remember you must keep it to the left of the plus or minus sign. So we get x equals 1 plus or minus 3. That's 2 equations. X equals 1 plus 3, which is equal to 4, and we get x equals 1 minus 3, which is equal to negative 2. So we get x equals 4 and negative 2. These are the 2 answers we found by factoring. And again, factoring was much faster, but there are going to be many problems that you're not going to be able to easily factor or factor at all. All right, so once again, this is the process we need for completing the square. Make sure your a is equal to 1. Isolate your 2 variable terms by themselves. Use 1/2 of b squared to find the missing term you need to turn this into a perfect square trinomial. And then from here, we use the square root property and then solve for 2 answers. Now, I put a star at this step. Why did I do that? Well, it turns out at this step, you get a shortcut. You kind of get that like cheat code into how we can factor the left side of our perfect square trinomial. So when I take a look at this, what is inside my parentheses squared, and this is the giveaway, it's going to be what's inside the parentheses squared, is -1. When I take a look to see what it eventually factors to, it was x minus 1 squared. And if we go back to the previous problem, if I can find it, there it is. I did the same thing here. So notice what was inside the parentheses squared. It's a +2. When I take a look at to see what this factored to, we got x plus 2. So it turns out the perfect square trinomial will always be x and then whatever is inside the parentheses squared at this point. So this is going to be very helpful when we have to add awful numbers, because we're going to see here in the next problem that not all numbers are going to be easy to work with. But by knowing this little trick, we can actually figure out immediately what the left side of this equation is going to factor to. It's going to be x plus or minus whatever the sign is in here squared. All right. So let's go ahead and take a look at problem number 7. So here in this problem, we can see we actually got an a of 3, and we're going to see that my middle term is not going to be an even number. All right, so let's do number 7. For number 7, we are given 3x squared plus 15x plus 24 is equal to 0. So again, we need to do this by completing the square, and we need two things when we complete the square. A must equal 1. So when we take a look at this problem, the coefficient out in front of x squared is not equal to 1. So if a does not equal 1, you must force it to equal 1. So that means here, we're not allowed to have any coefficient other than 1, so we must force this to become 1. Well, how can we do that? Here, if I've got a multiplication of 3, I can get this to be 1 if I were to simply divide this by 3. 3 divided by 3 is 1. There's my coefficient of 1. However, you can't just do this to one term in an equation, I should say, excuse me. So that means if I force this to be 1, if I divide this term by 3, you must divide every term by 3. So once again, if you have to force this to be 1, and in this case, to get rid of a multiplication of 3, I divide it by 3, we have to divide every term by 3, including the 0 itself. 0 divided by 3 is still 0. It's just when we have 0 in the denominator, that's when we run into problems. All right, so when I divide all these terms by 3, I'm going to get x squared plus 5x plus 8 is equal to 0. So now we got the first part done. A is now equal to 1. But the second part says we need to isolate the terms with variables in them. We don't have that here. So again, before I even start completing the square, we need to make sure it's in the correct form. I'm going to do that by subtracting 8 on both sides of the equation. We end up with x squared plus 5x, and then I'm going to keep a space because, again, we need to add something here to make this a perfect square trinomial. And this is going to be set equal to -8, and once again, we need to keep a space because whatever we do to one side of the equation, you must do to the other. So now we've got a equal to 1. We've isolated the variable terms. Let's go ahead and identify our a and our b. And now, to find the missing term we need to add, we're going to take 1/2 of b and square that. So here, if I take 1/2 of b and we square that, we're going to get 1/2 of 5 squared. Now, when you complete the square in this class, do not use decimals. Just don't do it, because decimals is going to make this problem much, much harder than it needs to be. And I'm specifically going to tell you on the exam that you are not allowed to give your answer in decimal form unless the problem states that. You will be given use of your scientific calculator for the entirety of this exam, but you are not allowed to put any answers in decimal form unless it's told to do so. Those directions will be on the exam. But coming back to this problem, half of 5, do not use the decimal 2.5. Keep this as a fraction. So what we get here is half of 5. 5 is a fraction over 1. 1/2 times 5 over 1 is simply just 5/2 squared. Now, this is the step where I get to use my shortcut. So without even finishing this and adding what we have to on top, I already know the left side of this equation must factor to x, and it's a positive 1 or 5/2, so it's going to be x plus 5/2 squared. Again, without doing any work at all, just by knowing this trick, we already know what the left side is going to factor to, and that's going to be helpful because we're going to show why in just a second. Now, we do need to finish this out, however. 5/2 is the same as 5/2 times 5/2, which is 25/4. In order for us to get a perfect square trinomial, we must add 25/4 to both sides of the equation. So that's what I'm going to do. We're going to add 25/4 to both sides of this equation. So this is what I mean. Sometimes we're not going to add very nice numbers at all. So the left side, we need to find two factors of 25/4 that have a sum or difference of 5. Now, this could be very tough to do if we're not very good with our fractions, but if we know this trick, we don't even need to think about it. It's a positive 5/2 inside the parentheses squared. It must factor to x plus 5/2 squared. Two factors of 25/4 that have a sum or difference of 5, that would be 5/2. 5/2 plus 5/2 is 10/2, which is 5. So on the other side, we're going to have to do a little bit of work. So here we have got -8 plus 25/4. Well, we're adding or subtracting fractions, so we need a common denominator. Every whole number is a fraction over 1, and then we need a common denominator of 4. I'm going to multiply this by 4 over 4. The left side still is not changing. We get x plus 5/2 squared. On the other side, we get -32/4 plus 25/4. And here we finally have the same denominator, so we can add those together. We get x plus 5/2 squared is equal to -7/4. Now look what we have. We have something squared equal to a number. We can use the square root property. And again, sometimes these numbers are not going to be nice numbers, but if you just figure out the pattern and know your basic fundamentals, right? You need to know how to add and subtract fractions. That's why you saw it on every single exam, and there's a good chance you're going to see it again on the next one. Just make sure that you know how to deal with fractions. Do not use decimals. All right, so let's go ahead and finish out this problem. So I'll just grab a second piece of paper here. And some of these problems do get pretty long. That's why this video is clocking in at the time it is, because it's a pretty lengthy subject. So I'm going to continue. I'm just going to rewrite what I have down here. We have x plus 5/2 squared is equal to -7/4. And all we need to do now is just use the square root property. So to get rid of the square on x plus 5/2, we take the square root. But anytime we introduce the square root, we must introduce plus or minus. Power matches the index. We're going to be left with x plus 5/2 on the left. And then on the right side, we get plus or minus the square root of -7/4. Now, there are many things wrong with this and why it's not simplified. First of all, we can't have fractions under a radical. Second of all, I see a negative under a square root. This means we must split this into its real and imaginary part. Anytime you see a negative under a square root, your first move must always be to split it into its real and negative portion. So we're going to get x plus 5/2 is going to be equal to plus or minus the real part, which would be the square root of 7/4, times the square root of -1, the imaginary part. The imaginary part will never be anything other than the square root of -1. So rewriting this, we get x plus 5/2 is going to be equal to plus or minus. Here, I notice that I've got a fraction under a radical. Let's use the quotient rule. So this is the same as the square root of 7 over the square root of 4. And then the square root of -1 is simply just I. Here we can simplify the square root of 4. So we get x plus 5/2 is equal to plus or minus the square root of 7 over 2i. And then finally, to get x by itself, we have an addition of 5/2. We can subtract 5/2 from both sides of the equation. Again, anytime we add or subtract, we must keep it to the left of the plus or minus sign. So we can subtract -5/2. And that gives us a final complicated answer that x equals -5/2 plus or minus the square root of 7 over 2i. And there it is, our answer in standard form. So let's go ahead and put this back into the correct order. Notice everything that needs to be done, and I'll even let you know right now, you will have a problem very similar to this on your exam. So make sure that you understand how you got through this problem. So what we need to do is make sure we have the two things in place to complete the square. A must equal 1. If it doesn't, you must force it to equal 1. To get rid of a multiplication of 3, I divided by 3, but that means we have to divide every single term in the problem by 3. Then we need to get the two variable terms by themselves by subtracting 8. Leave yourself a space. To get a perfect square trinomial, we take 1/2 of b and we square that. We get 1/2 of 5. Do not use decimals, use fractions. And here we get 5/2 squared, which is 25/4. We add that to both sides of the equation. Using our shortcut, we know that this automatically must factor to x plus 5/2 squared. On the other side, we needed to do a little bit of work to deal with our fractions. And then from here, we get something squared equal to a number. Take the square root property, simplify using what we learned in exam number 3, and then finally end up with our final answer. We are allowed to get complex and imaginary answers. Those are still very much answers to these problems. So here, the two answers would be -5/2 plus 7, or square root of 7 over 2i, and -5/2 minus the square root of 7 over 2i. All right, so there you go. That's completing the square. Please use this video if you are getting stuck on future problems, because completing the square is a very tedious process, but it's just something you're going to need to know, because when you get to section 15.1 dealing with parabolas, we are going to be looking at the standard form of a parabola. The only way to get the standard form of a parabola is to complete the square. So once we learn the quadratic formula here, most of you are going to change to that, because the quadratic formula is by and far the easiest to use outside of factoring, of course. But we still need to know how to complete the square. And again, I'm going to require you to do all 4 methods on your exam anyway. All right, so enough blathering on. Let's go ahead and take a look at the next problems. Here, for 8, 9, and 10, we want to solve using the quadratic formula. Now, hopefully, the quadratic formula is something you've seen in your high school algebra classes, and this is just a formula you have to memorize, because on your final exam, every single final exam I've ever seen for Math 105 has had the same question every single time. For 4 points, write out the quadratic formula. So you need to know this anyway for this exam, so you just need to commit it to memory. So let's go ahead and take a look at the quadratic formula and how it's used. If I can get this piece of paper off. There we go. So the fourth method in the quadratic formula, first of all, the reason why students love this so much is a can be any number. So unlike completing the square, where we had to force our a to be equal to 1, here when we use the quadratic formula, a can be any number, and we can get both real and imaginary solutions, which means the quadratic formula works every single time. So to use the quadratic formula, it's going to be x equals the opposite of b plus or minus the square root of b squared minus 4ac and this is in a fraction over 2a. A, B, and C come from the standard form of quadratics, which means in order to use the quadratic formula, just like with factoring, we need to set one side of our equation equal to 0. And it's as simple as substituting in your numbers once you find A, B, and C, and then just simplifying. Now, when you substitute in any math class, you should always substitute using parentheses. And the reason why is it's going to help save with sign errors. This is the opposite of B, which means if my B ends up being -2, this would be minus a -2, which would end up being a +2. So to save yourself sign errors, always substitute using parentheses. All right, so here for number 8, we simply just want to use the quadratic formula. So the problem that we are given is x squared plus 4x plus 1 is equal to 0. So this is a case where you cannot factor this because we need two factors of 1 that have a sum or difference of 4. Those don't exist. So instead what we need to do is use our other methods. We couldn't use the square root property because we have a middle term with a variable in it. We could complete the square. That would work every single time as well. But here the directions say specifically use the quadratic formula, and it's realistically the one you're going to default to anyway because it's the easiest to use. So all you need to do for the quadratic formula is make sure that one side of your equation equals 0. Here it does. So all we need to do is identify our A, our B, and our C. Our A is the coefficient out in front of x squared with nothing written, it's 1. B is the coefficient out in front of x, which is a +4, and C is the final constant on the end, which is a +1. Now that we have A, B, and C, all you need to do is substitute these values into the quadratic formula. So what we're going to end up with is x equals the opposite of b, which is 4, plus or minus the square root of b, which is 4, squared, minus 4 times a, which is 1, times c, which is 1. And then this whole thing is sitting in a fraction over 2 times a, which is 1. So notice all I did here was just substitute my values using parentheses. Now we just simplify. So we're going to get x equals -4 plus or minus the square root of 4, the square root of 4 squared is 16. Now, what we need to understand here is in my radicand, we have got two terms. So we got 4 squared minus and then this group of multiplication, which means when we do the quadratic formula, after we take b squared, we must have either an addition or subtraction sign after this. So here we got -4 times +1 times +1. We end up with a -4. So again, we will always have a plus or minus sign after we take b squared inside the radicand. Now, this whole thing is sitting over 2 times 1, which is 2. We can simplify this radical. So we get x equals -4 plus or minus the square root of 12 over 2. I can simplify this radical, 2 factors of 12 where we know the square root are 4 and 3. So this is the same thing as saying -4 plus or minus the square root of 4 times the square root of 3 all over 2. So simplifying even further, x equals -4 plus or minus 2 square roots of 3 over 2. And then the final thing that we want to do is split this up into two fractions. So we will end up with -4 over 2 plus or minus 2 square roots of 3 over 2. And we can simplify this first fraction to give a final simplified answer of x equals -2 plus or minus 2 square roots of 3, And then, I wasn't even paying attention. We've got a 2 on top. We've got a 2 on the bottom. We can actually cancel those factors. So we don't even end up with 2 times anything. We simply just get the square root of 3. And there you go. That's the quadratic formula in a nutshell. Identify your A, B, and C, where A can be any number. It does not have to be 1. substitute using parentheses, and then simply simplify until you get your final two answers. And there we go. Those are our two answers, -2 plus square root of 3, -2 minus the square root of 3. So again, I think it's going to be a lot more helpful just to show you rather than try to explain this fully. So let's take a look at the next problem. Here, solve using the quadratic formula. We get 4x squared minus 2x equals 4. So once again, 4x squared minus 2x is equal to 4. And we want to use the quadratic formula. So again, when it comes to this, and there's a reason I did this on every single one of these methods, is there are specific forms it needs to be in order to use these. Make sure you understand which form it needs to be. And the simplified method is always set one side of your equation equal to 0 unless you are completing the square or you're using the square root property. Excuse me. So here we do not have this set equal to 0. So before we identify A, B, and C, you must set one side of your equation equal to 0. So I'm going to start by subtracting 4 on both sides of the equation. We get 4x squared minus 2x minus 4 is equal to 0. Now, you could simplify further if you wanted to. If you notice, all of these are divisible by 2. We actually could divide out 2, but it's not required. Why? Because with the quadratic formula, it doesn't matter what A is equal to. So that means we get to jump immediately to identifying A, B, and C, and then just substitute them into the quadratic formula. A is going to be a positive 4, B is going to be a -2, C is going to be a -4, and now we just substitute. So we get that x equals the opposite of b. So we get the opposite of -2 plus or minus the square root of b, -2 in parentheses squared, minus 4 times a, which is 4, times c, which is -4. And then this is all over 2 times a, which is 4, excuse me. So again, by substituting using parentheses, this will help with sign errors in many different places. So all we need to do now is just simplify. So here we get x equals, which is going to be minus a -2 is positive 2, plus or minus the square root of -2 in parentheses squared is 4. We need either a plus or minus sign here. So here we are going to get -4 times positive 4 is -16. -16 times -4 is a positive 64. And this is all over 2 times 4, which is 8. So we can simplify that radical. We're going to get 2 plus or minus the square root of 68 all over 8. Now, this is the other tough thing about classes like this. We are ending up with a number of 68. We need to find factors of 68 where we actually know the square root of one of those factors. That can be very difficult to do. So in this particular case, it might just take you a minute. So here I notice that I have 68. This is divisible by 4. I know 4 is at least, I know the square root of that. So let's see here. 4 times 22. No, that's going to be too many. So I have to think about it myself. It looks like it's going to be 4 times 17, right? 4 times 17 ends up being 68. So sometimes these factors, honestly, sometimes these factors are terrible. Even I had to think about that for a second. So here, 4 times 17, and I even just want to prove this to myself. Maybe let's do it up here. 17 times 4. We're going to get 8, carry the 2, and there it is. It is in fact 68. So here you will have a calculator for this exam which can help you out, but we still need to find factors. Those two factors are 17 and 4. So we can write this as x equals 2 plus or minus the square root of 4 times the square root of 17. And this is all over 8. Simplify the square root of 4. We get 2 plus or minus 2 square roots of 17 all over 8. We can break this up into 2 fractions. So we get x equals 2 over 8 plus or minus 2 square roots of 17 over 8. And then we can go ahead and cancel factors. So here 2 and 8 are both divisible by 2. 2 and 8 are also divisible by 2. and we get our final simplified answer. Here, x equals 1/4 plus or minus the square root of 17 all over 4. So again, some of these numbers are not going to be nice at all. We just need to be very confident in the procedure on how we actually go through and do all of these methods. So even though the quadratic formula is the easiest method, we can see it still can trip you up. Finding factors is going to be very tough, but we also need to make sure that we are always simplifying as far as we can when it comes to these problems. All right, so I want to take a look at one more problem. I know this video is very long, but I'm hoping that it's going to be helpful for some of you that need extra help trying to understand these methods, because that's what this entire exam is about, is literally using these 4 methods. All right, so the final problem that I want to go through, number 10, we have x squared equals 2x minus 7. So we still need to solve using the quadratic formula. And again, it does not matter what a is. The only thing is you need to make sure that we have it in the correct form. So here we get x squared is equal to 2x minus 7. In order for us to use the quadratic formula, one side of my equation needs to equal 0. So the first thing I'm going to do is subtract 2x and add 7 to both sides of my equation. Now, you technically can go ahead and subtract x squared over to the other side because it doesn't matter what a is. It can be a -1. There's nothing wrong with that. I just like to keep my a positive, but again, you actually could have brought this over to the other side and you'd still get the same answer. So what we end up with is x squared minus 2x plus 7 is equal to 0. So we can identify my a, b, and c. A is the coefficient in front of x squared, nothing written, it's implied to be a 1. B is the coefficient in front of x, that's going to be -2. And then c is the final constant and its sign on the end, which is a +7. Now all we need to do is just substitute these numbers into the quadratic equation, or excuse me, quadratic formula. So what we're going to end up with is x equals the opposite of b, which is -2, plus or minus the square root of -2 squared minus 4 times 1 times 7 all over 2 times 1. So again, all we're doing here is just substituting using parentheses. Just make sure you're putting the numbers in the right spot. I've seen students accidentally put the wrong numbers down. And from here, we just want to simplify. So we're going to get x equals +2 plus or minus the square root of -2 in parentheses squared is 4. Again, we need either plus or minus after this. I have -4 times a +1 times a +7. That's a -28. And this is sitting all over 2. We can simplify this radical. So we're going to get x equals 2 plus or minus the square root of -24 over 2. Anytime we see a negative under a square root, your first move must be to split it into its real and imaginary parts. So here, this becomes 2 plus or minus the square root of the real part, the square root of 24, and then the imaginary part, which is always the square root of -1. It will never be anything else. And this is still sitting over 2. Need another piece of paper. So continuing on, I notice that I have the square root of 24. We can use the product rule to break this up. So here we're going to get x equals 2 plus or minus 2 factors of 24 are going to be 4 and 6. So the square root of 4 times the square root of 6. The square root of -1 is going to be I. And this is all sitting over 2. We can simplify further. X equals 2 plus or minus 2 square roots of 6 I over 2. And then the last thing we need to do is split this up into 2 fractions. We get x equals 2 over 2 plus or minus 2 square roots of 6 over 2, and then I. And then finally, we can see we can simplify. So our final simplified answer is x equals 1 plus or minus the square root of 6 times I. So there it is. These are all 4 methods that we need to use when it comes to solving for quadratic equations. So we were able to take 10 problems, and all 10 of these problems, by the way, are going to be very similar to problems you see on your exam. So make sure that you understand how to do this. And then likewise, we also need to make sure we understand all the methods. So again, factoring is always going to be the fastest method if possible. You're going to find yourself factoring in this exam, but all the problems are going to have directions stating specifically how to solve these problems. So with factoring, make sure you set one side of your equation equal to 0. The square root property says we just need some factor by itself squared equal to a number. Completing the square, you must have two pieces. A must equal to 1, and if it doesn't, you must force it to equal to 1, and then make sure you get the two variable terms by themselves. Also, when it comes to completing the square, make sure that you find the missing term you need to get a perfect square trinomial, which just means we get two factors that are identical that we can rewrite in terms of exponents. And then finally, we have the quadratic formula, which most, if not all of you, will revert to because it's the easiest, most straightforward method to use. All right. So this is pretty much all I needed to cover for this particular video. So this exam can be very tough if you don't start practicing your problems earlier. There's actually a lot of different variations of problems that we are going to see for this exam, which also makes it very difficult. So this is just dealing with quadratics. Eventually, we're going to get into something called U substitution. We're also going to take a look at how we can graph inequalities, and in this case, nonlinear inequalities. And then at the very end, we're going to talk about parabolas. And parabolas is the shape you get with any quadratic equation. But we're going to find many specific things we're going to have to do later in those problems to the point where I'll probably end up making another video. So if you made it this far, I do apologize for this being so long, but I did think it was very important to actually go through and show you all these different methods because obviously that's what this next exam is all about. So if you can deal, and I shouldn't say deal, right? I'm trying to think of better words. It's getting late here. If you can actually go through all 10 of these problems and you know how to solve all of them using the correct methods, you should feel very confident going into the other portions of this exam that aren't exactly going to look the same. All right, so that's all I got for you in this video. We will see you in the next one.